Hello, good evening. This is Santiago Hernandez, and this is for my Physics 2 project. So this is the circuit here. Some schematics, whatever I could reference. It's an amplifier, pencil. So basically, what's going on here is it's a very, very, very basic circuit, or like synthesizer, and it uses if I could get this little chip here is a 555 timer, and this chip right here is an operational amplifier. It's not really needed, but it was just thrown in there for fun. So basically, how this is currently set up is it's set up in astable mode. So if we were to look here, this is a very rudimentary drawing of the pinouts because I'm not sure how to learning. But basically, to set up in astable mode, we connect pin 2, which is right here, the trigger pin, to your capacitor, and we jump this pin all the way to pin 7. No, sorry, should be pin 6, which is around here. Yeah, connect to pin 6, which is this green jumper cable here, and then from there you connect the resistor to pin 7, which in this case is from this yellow wire, connects to pin 7, just trust. From there it goes to this potentiometer. The output of this potentiometer then goes into pin 7, and yeah, this is basically or in our case, it varies the resistance, so it'll be changing the frequency of the oscillations. And from there, the other pins are mostly like pin 3 in our case, or in this case here, is the output pin. So from here, it's just running through a resistor and a capacitor, so we could decouple it, just this big one here. But yeah, in terms of the 555 timer, that's how we have it set up. It's in astable mode. This changes the resistance on the the threshold pin, and yeah, it's in astable mode. From there, we have this op amp here, and this only we're only using it as a buffer. So we have the 2 buffers here. Basically, right after the output, it goes into here, and it gets biased, 4.5 bias, which over here in the top corner, this is our voltage divider. So, and this is a capacitor, just clean up the sound a bit. But this is a voltage divider, and from here it runs into another op amp, like one of the op amps. From here, just make sure that it's it gets a nice 4.5 volts. So that's all nice and dandy. Then afterwards, it gets right here. It's combined with the output of the 555 timer, and then it runs into another an op amp, and this just makes sure that the output of the timer, like the square wave, it's nice and stable. And back to the 555 timer, essentially, the more resistance, the longer it's going to take for the capacitor to charge. Therefore, the overall frequency time duty is going to be much slower. In this case, we're using a small capacitor here. I believe it's just double check. Should be a 0.1 microfarad capacitor. It's quite small. And later on, after demonstrations, we're gonna jump up to a 1 microfarad, if they could focus, a 1 microfarad capacitor, and you'll see that's gonna be a different, overall sound. It's gonna be a lot slower. And after that, we just have a low pass filter, which is this one here. and a high pass filter over on this side. And this is low pass, high pass. Pretty much right now it's just connected straight to the output. And it's a little amplifier, you know. Well, I'll show some effects later on, but I'll first show the raw audio. But yeah, so let me, what's it called? Turn the volume up. Turn effects off too when I'm at it. So this is the volume. So at its lowest point, this is the slowest it's gonna go. And then from there it's just a bit too fast. So yeah, that is, in this case, how we have it set up is so pretty much what's happening is, as it's going this way, it's pretty much bypassing the resistance inside. So it's just pretty much being controlled by this resistor here, which is pin 7 with discharge. But yeah, that's that. Let me showcase the small filters. So I need 2 hands for this, but output changes. We'll go low pass here. And then we need this pin here to connect to this pin here. It should work. Okay. Yes. Alright, so this is a low pass. So this is fully open, and it's not too noticeable, but it kind of gets a bit muffled. And basically what happens is, clicking the page here, this is the low pass, so it runs through the resistor, and then it runs through the capacitor to ground, and this is the coupling capacitor for the output. But yes, this is how that works. Essentially, low frequencies, you know, they charge up the capacitor. My understanding, they charge up the capacitor, and when it charges, it basically prevents the low frequencies from going through, but it allows the high frequencies to pass by like nothing. And the opposite here, it charges, therefore the low pass, like the low frequencies go through and the high frequencies go through. But that's basically the low pass filter. Put the volume back down, get rid of this wire, move the output over here, and then connect the high pass. Okay. Right, there's should be unfiltered, and as we go up here, kind of, it only allows everything above a certain frequency to go. And same concept up here. This is low, high pass, and try it in the middle. That's that. Let me go ahead and connect this. Apologies for the cut. This phone needs an update. But yes, let me go ahead and connect this. Wait 1 second. Okay. All right. Put the volume up. Before I put the powder in. So So with a much larger capacitor, as you can see, the frequency is quite low. So the range isn't as good, but so yeah, larger capacitor, the longer it takes to charge and discharge, therefore a slower overall wave and frequency. But yeah, right, actually I would showcase it with some effects. So let's say we go, now the effects isn't part of this circuit, but it just shows like some cool stuff you could do with it. You know, some effects, and in general it'll just be much more complicated than this, but this is how ours is working right now. But yeah, so this is our project. Hopefully the video isn't too long. Yes, we'll be linking this to the page or paper. Yeah, this is our circuit.